Well, welcome back in today's video of post-order traversal. Previously, we have observed in phase, in order and pre-order. So today we'll be observing the post-order. So before we understand the post-order, let's understand the general tree structure. So in general tree, we just have a root at the intermediate position, the root. So that is the root, and there is left side and there is the right side. And we call it in order. We call it in order, the normal order. And if we just bring the root node in the post position, so the orientation becomes like this: left, right, root, left, right, root, and we call this order the post order traversal. Post order traversal. So we understood that post order is nothing but left, right, root. So let me write the post order traversal. Post order. So post order ordering is simple. First there will be left, there will be right, and then there will be root. This way, and this is the post order traversal. So now, as we know that how post order works, first it will process the left elements, then it will process the right elements, then it will process the root elements. So it's easy to understand. Now I will just show you the code, and then we will try to understand that how we can get it. So the base case is whenever we encounter null, we stop the program. So we'll be writing that condition. So it becomes like this: public void post order, and in the post order function we just pass the this is the root node. We pass this root node initially. So this root node is of type binary tree node. So we'll be passing binary tree node, binary tree node root. We pass this binary tree node root, and then now we check the condition. Look, we came from here. So first we'll be processing the left element at its tail. So we'll be processing left, and again when we'll process left, this is also having this tree structure. Then again we'll process the left, and then again it is having this tree structure. And then when we come to here, we'll be again trying to process this left, and now it will encounter a null, and once it encounters null we will just stop. So this is the criteria, that when we stop is when we encounter null. So we'll be writing condition with respect to that, that if root not equals to null. That means if root not equals to null, then we will be running the program. If root is null, then we'll just stop the program. There is no logic to move forward. So we just stop here. And then what we are processing? We are just processing the left. Again left. Again left. So we'll be processing post order left. Post order root dot left. Now we have processed the left. Now we'll be processing the right. So once we have done it in left, it becomes the current root. Every time we come here, first it was our root. One thing is to notice that first time it was our root, grand root. It was our root. It just didn't got updated the root. So it was our root in the first time. Second time when we came to this position it became our root. And third time when we came here, this became our root. So here we check both this side, left side, and then we check the right side also. That also encountered null, and so we are returning. So when we check this side, we check this side, and then we'll be checking that side. So we'll be observing the 40. We'll be observing 40, the right side. So if we come in that section, after we have done with the entire left child, entire major left child or left tree, now we'll be observing toward the major right tree. So this is the right tree. So when we come to the right tree, again this is also having architecture like this, architecture like this, and architecture and like this, and we'll follow the same principle: left, right, root. So we have already observed the left one. We'll notice the right one. So we'll be processing like this, right, then again we'll be processing like this, but after left, and then once the right has been done, we'll be processing the root. So we'll be writing post order root dot left, then post order root dot right, and once we have processed the root dot right, we'll be simply printing the root of all. System dot out dot println root root dot data will be printing the main data. So okay, ending of loop, ending of the formula. So if we just apply this three lines of code, it will print, it will traverse all the tree. And then now we'll be understanding that how it prints, that how our console printed the same things. So first we'll be noticing that things in our console, and then we'll verify that what console printed, console and us. We'll be noticing that one. So let's observe in the console or zip 2. So this was the place where we are writing the tree. Now we'll begin writing the next tree. So previously we have wrote in order pre-order. Now we'll be writing the post order. Public void post order binary tree node. And now this is root. So first we check the base condition that if root not equals to null, and then post order root, we first post the left portion, so root dot left, and then we pass the right portion, so that is post order root dot right. Once we have processed the left and right, now we process system dot out the root one, print ln root dot data. Okay, so we just wrote the code. Now let's change in the main function that pre-order traversal. Now instead of pre, we'll be observing the post-order traversal, post-order traversal, and this is pre not post-order traversal, post-order traversal. Okay. Now we change the program, so we'll be saving the file and compiling again. Java compile, Java, and notice what we are getting here. We'll be noticing here. We got the post-order traversal to be like this. In console, we got first we got 20, then we got 40, and then we got 30, and then we got 60, 60, 100, 70, 50, 70, 50. Now we'll be trying to understand that how we can get the same in our program. Okay, so move back to the program. That is the output that we got from the program. So let me just remove that section. Okay, left, root, right, that we don't require. I don't know from where I got this is left. Okay, left, right, root. Now we'll be trying to understand from this example that how we can get the same. So notice first we got 20 from the console, and now we'll be implementing by ourselves. So we start from this root node. We start from this root node, and when we get first we'll be processing the left tree. We'll again keep processing the left tree. So when we got the root node, we come here in the left section, and again we got the left node, we come here in the left section, and now we process the left, we got null. So when we got null, we just leave, we ignore, because now it will not get executed. So ignore, and we just print the data portion. So we printed the data portion 20. Okay, we printed data portion. Now it comes in the here, this is the root, but what we process the right one, so we print the 40, this is the right one. So 20, 40. After this left, this is left portion, this is the right portion, and now we process the root. So now we'll be printing the 30, root one. So this is we printed. Now this is the entire grand root, that is the grand root. This is called the grand left. We have processed the grand left. Now we'll be processing the grand right, and this entire section is the grand right. So we'll be now processing the grand right. So let me just remove few portions. Okay, now we come to here in the right section from 70. In 70, when we come to here, this becomes the root again. So we again process the left as said. So left we again process 60. Then we process the right as said. We process 100. After that we process the root 70. So once the left and right of this grandparent has been done, now we process 50. And now notice 20, 20, 40, 40, 30, 30. 60, 60, 100, 100, 70, 70, 50, 50. So this is how the entire compiler and the code and the program works, and this is how we have to think like a programmer. So that's all about post order. We'll be meeting in the next video.